A warm welcome to everybody listening. This is Bernd Jene. I am one of the members of EMVA's board of directors and the chair of the 1288 standard. This globally accepted standard is for objective characterization of cameras, and recently release 3.1 has been published, and with a number of short video messages, we are going to explain you the highlights of this globally valid standard. Today's topic are the basics of the EMVA 1288 standard. How does it work at all? How can you do really an objective characterization of cameras? Well, fortunately, the physics of imaging is good understood. A number of photons are hitting actually the pixel area during the exposure time. They create a number of charge units. They are collected at a capacity, being amplified and digitized so that finally you have a digital gray value. So in a sense, photons are converted into digital gray values. This process is for all cameras the same, and so the approach taken in the EMVA 1288 standard is a black box model. Photons are coming in and digital gray values are coming out. The question is now, how do we have to fill this black box? What are the essential parameters of this camera so that we can do measurements without really having to do anything within the camera? Well, this is actually easy as long as the camera is linear, and this is the case for almost all cameras you are using. And then you can take a two-stage approach. First, in the first stage, photons are converted into charge units with a certain efficiency, which is called the quantum efficiency. And then this signal is amplified and digitized to finally give a digital number. The more complicated thing is to describe the noise. But with a linear system, we have the fortunate situation that all noise sources can be put into a single source called dark noise. And then we have, in addition, only the photon noise itself. And in this way, we end up with a simple model which has, in a sense, three parameters. The first one is a quantum efficiency. The second one is the standard deviation or the variance of the dark noise. And the final one is the system gain, K. These are all the red numbers you see in this diagram. This basic three unknowns can be estimated by two measurements. First, the mean digital gray value has to be measured as a function of the number of photons. This is the sensitivity curve. And secondly, the variance of the noise in the image has to be measured as a function of the mean digital values. Then, after these measurements, we know all these three basic parameters.